Now I know this next part of my video is going to be kind of short, and I hope that sun didn't blind you too much. Okay, we have 3x plus 5x equals 8x. The 3, the 5, and the 8 are numerical coefficients. I covered this in a previous video, but I wanted to prove it out to you that you can add up these numerical coefficients and be fine, alright? Now, let's say that x is 4. Well, if you remember your basic rules of arithmetic, you have to multiply and divide things before you can add and subtract them. Therefore, 3 times 4 is 12, 5 times 4 is 20, and 8 times 4 is 32. Well, 20 plus 12 is 32. Well, 5x plus 3x is actually equal to 8x. 5 plus 3 is 8. And that's it. Right there. Okay? So, as long as you have like terms, and these are like terms, x here is a like term, this is a like term, it's just like, and I'm going to write this down for you really quick. Hopefully my head will block the sun for a second. X squared, x squared. They're like terms. Why? Because they're x squared. Okay? Same type of deal here. This x here is exactly the same as this x here, and this x here is exactly the same as the other two. Alright, they all represent 4 in this case. They won't always, but they represent 4 in this case. So, this term and this term and this term are like terms because they all three have an x. None of them have an x squared or an x cubed or some sort of x to the 4th or anything like that. Alright, they're all just x. Alright, they're not y's, they're not z's, they're not anything else. But the reason why I had to present this is because I'm going to present the last part of this, and hopefully, finally, all this stuff will start making sense to you. I will tell you more in a future video, so stay tuned.